Hello everyone, my name is Ravash Mota, pursuing Instrumentation Engineering from Swami Vivekanand College. Along with me, my group members Kartik Wankade, Shweta Gadve and Prathamesh Pawar. We have worked on a project, brain tumor identification using convolution neural network. Under the guidance of Professor Amuda Shendil Kumar, we have worked on this project.
So the presentation will go in this flow. We will start with the brief introduction of the project, then the motivation for the project, problem statement, different types of tumors, and the software that we used, and then the final conclusion. Medical imaging is a technique and process of creating visual representation of the interior of a body for clinical analysis and medical interventions, as well as visual representation of the functions of some organs or tissues. Medical imaging seeks to reveal internal structure hidden by the skin and bones, as well as to diagnose and treat disease. An image processing technique is the usage of computer to manipulate the digital image. This technique has many benefits such as elasticity, adaptability, data storing, and communication. With the growth of different image resizing techniques, the image can be kept efficiently. This technique has many sets of rules to perform in the image synchronously. A brain tumor is defined as an abnormal growth of cells within the brain or central spinal canal. Some tumors can be cancerous, thus they need to be detected and cured in time. The exact cause of brain tumors is not clear, neither is the exact set of symptoms defined. Thus, the people may be suffering from it without realizing the danger. Primary brain tumors can be either malignant, which can contain cancer cells, or benign, means do not contain cancer cells. Brain tumor occurred when the cells were dividing and growing abnormally. It is appearing to be solid mass when it is diagnosed with diagnostic medical imaging techniques. There are two types of brain tumor, which is primary brain tumor and metastatic brain tumor. Primary brain tumor is a condition when the tumor is formed in the brain and tended to stay there, while the metastatic brain tumor is a tumor that is formed elsewhere in the body and spread through the brain. The symptoms having the brain tumor depending on the location, size, and type of the tumor. It occurs when the tumor comprising surrounding cells and gives out pressure. Brain tumor can be detected by the diagnostic imaging modalities such as CT scan and MRI. The MRI is the most regularly utilized strategy for imaging brain tumors and the identification of its vicinity. MR images are mainly used because they are non-destructive and non-ionizing. MR imaging offers high-definition pictures that are extensively utilized in discovering brain tumors. There are many imaging processing techniques such as pre-processing, segmentation of image, image improvements, feature extractions, and classifiers.
So now let's look at the problem statement. So the focus of this project is MRI brain image tumor extraction and its representation in simpler form. The objective of this work is to bring some useful information in simpler form so that the medical staff treating the patient can use it. The aim of this work is to define an algorithm that will result in extracted image of the tumor from the MRI brain scan. So the result of this whole work would be to provide information like size, dimension, position of the tumor. Let's look at the scope of the project. Our aim is to develop an automated system for enhancement, segmentation, and classification of brain tumors. This system can be used by neurosurgeons and healthcare specialists. The system incorporates image processing, pattern analysis, and computer vision techniques and is expected to improve the sensitivity, specificity, and efficiency of brain tumor screening. The primary goal of medical imaging projects is to extract meaningful information from these images with least error possible. Now let's look at the types of tumors. So there are basically three types of tumors, namely glioma, meningioma, and pituitary. The glioma originates in the brain but can be found in the spinal cord. The meningioma originates in the meninges, the outer layer of tissue that covers and protects the brain just under the skull. The pituitary adenomas develop from the pituitary gland and tends to grow at a slow rate. Now, our module division starts with the input of the image into the model. Then the image would be pre-processed. After that, the image would be enhanced, where the image would be divided into multiple layers and enhanced accordingly. The next step would be image segmentation using binary thresholding. After this step, the next step would be brain tumor classification using convolutional neural networks. After all these above steps are done, we will get the output, which will define if the input image has a brain tumor or not. So these are the hardware and software requirements. In the hardware requirements, the processor needs to be Intel and it needs to be 64-bit quad-core processor. The RAM needs to be 4 GB or more. The hard disk should have a minimum of 10 GB of space available. The display should be dual XGA and the operating system needs to be Windows. In the software part, we have used Python, NumPy, Pandas, Anaconda, Jupyter Notebook, TensorFlow, and lastly, Keras OpenCV.
The libraries which we import are Globe. Globe is the short form of global. It is used to return all the file paths that we match in a specific pattern. The next library which we use is Pandas. Pandas is the most popular Python library which is used for data analysis. We can analyze data in Pandas with series and data frame. Then comes Matplotlib. Matplotlib helps us to perform the function in a graphical form. NumPy library helps us to deal in the mathematical conditions. CV2, it is an open source library. Keras. Keras is the library which is used for deep learning models. VGG16 helps us to improve and give us more accurate results. TensorFlow library comes under Keras. TensorFlow is an open source software library that allows data flow of the different programmable access of a range of tasks. It is used for both research and production at Google. Then comes Keras models. It helps us to train the models. Layers, callbacks, metrics are all functions of Keras. Then we import warnings to help us to know when the warning error occurs. Next step. Then we import the Google Drive in which we mount all the specific given folder. Then the function is used to load the given images. We convert the image into dataset. We give a specific path in which it will locate the path and it will find the image where the image is. Then the function to convert output labels to classify the tumor, whether it is glioma tumor, meningioma tumor, whether it is pituitary tumor or no tumor. Then the data is set to train and test. In train, we train the data set. For example, after the training is done, now we perform the testing on the data. After the testing is done, the visualization data set is as follows. It is plotted in a graph. Okay, a little lower. Where the melanoma tumor is 28.96%, glioma tumor is 13.68%, no tumor is 28.51%, and a little lower. And pituitary tumor is 28.89%. After that, the figures are plotted in the given range. After the graph is performed, the figure is cropped in the following manners. Little lower. The size and weight of the figure is given. When we can detect that if there is tumor or no tumor or which kind of tumor is there. A little lower. Okay. Now the callback functions. It is to detect the intent of the TPU. TPU means it initializes the cluster of the function in which TensorFlow allows to buffer the TPU system. After that, we train the CNN approach. With that, we add the CNN shape of giving. Then the max pooling layer is done. After that, the convolution 2D layer is performed. After that, batch normalization is performed and we give a defined shape and attribute to it. A little lower. Now the model is prepared. These are the following steps how the model will be prepared. First is max pooling, then the layer input, then the 2D convolution, then the max pooling, then batch normalization, then convolution 2D, then again max pooling 2D, then flatten, then dense. Okay, after that, the dropout and dense part again. After that, the figure is plotted. After the number of given accuracy and validation accuracy, a graph is plotted with the help of Matplotlib. As we can see, the yellow line shows the accuracy and the blue line shows the validation accuracy. Then again comes the validation loss figure. In this, the validation loss is detected in the blue line and the yellow line shows the loss. Now, the predictions of the data set is happening with the help of CNN model. These are the predictions in the following manner. Okay, these are the predictions. After that, the transfer learning approach is helped. For example, transfer learning approach, that is VGG model, performs the given function. We use VGG to make it more accurate. With the help of VGG, we can show that more accuracy is to be formed in the brain tumor effects. After that, a plot model is done. After that, we again train the photos for more accuracy with the help of VGG model. Now the accuracy will increase. After performing VGG, the validation accuracy and accuracy in the graphs are shown as below. Now the accuracy of it increases, as we can see. The blue line is a little lower and the accuracy rate is higher. The yellow line. Okay. And as you can see, the validation loss decreases and the loss is very less this time. With the help of VGG model, the loss decreases. Now the prediction of the dataset using VGG model has a great spike, which shows around a great validation accuracy. The accuracy is a lot better with the help of VGG model. The average is around 92. As you can see, the precision is 0.94. The VGG16 model, the following are some images which are with the help of VGG model. And now the following image, a little lower. These are the images which uses CNN model. They pick up randomly image, a random image is picked and it is shown the accuracy. Conclusion. Here we would clearly observe that both the approaches work quite well, with not much difference in the accuracy. Though VGG16 model worked quite more efficient because there were two reasons. First, the validation accuracy and the test accuracy is higher than the other method. Second, time and computation and the computation power is required lesser than traditional method as pre-trained weights are used. Thank you.